Moving further, we have with us Professor Yoon-Fah Lay from University of Malaysia, Sabah, Malaysia. He is associated with Science Education at the Faculty of Psychology and Education, University Malaysia, Sabah, Kota Kinabalu, Sabah, Malaysia. He holds more than 29 years of working experience. He obtained his PhD in Science Education, MSc in Human Resource Development, and BA Education Honors in Chemistry and Commerce. Primary research interest of Professor Lay includes in the area of scientific skills, logical thinking abilities, attitude towards science, environmental education, professional development of science teachers, and international comparative studies. I request Professor Lay to initiate his invited talks on structural equation modeling, approach in education and psychological research. Over to you, Professor Lay, for your invited talk.
Okay, can you hear me?
Yeah, I can hear you.
Okay, good afternoon. Thanks, Madam MC, for the kind introduction. Ladies and gentlemen.
Please turn on your video. Please turn on your video.
Okay. Okay, I'm Professor Dr. Lay from the Faculty of Psychology and Education, University Malaysia Sabah. So thanks for giving me the opportunity to share with you the use of structural equation modeling in educational and psychological research. Okay, can you see the slide?
Yes, we can see your slide.
I can't see my slide here.
We can see your slide which starts with statistical analysis is an important research skill.
Okay, it's okay. I will just based on my PowerPoint. Okay, first of all, I just want to highlight the use of second generation statistical technique, structural equation modeling in educational and psychological research. Okay, so when we say structural equation modeling means we are talking about partial least squares and also covariant based structural equation modeling. Okay, so I will highlight some of the current issues and challenges of statistical analysis in educational and psychological research. So when you say quantitative analysis, so in terms of statistical methods, often used by social scientists, for example, educationalists and also psychologists, they are typically called first generation statistical techniques. And these techniques may include regression-based approaches, for example, multiple regression, logistic regression, analysis of variance, and confirmatory factor analysis, in short, CFA, and also some techniques like exploratory factor analysis, EFA, cluster analysis, and multidimensional scaling. So all these are the first generation statistical techniques used by social scientists in quantitative analysis. So when applied to a research problem in education or psychology, these methods can be used to either confirm a priori established theory or identify data patterns and relationships. It depends on the objective of the study carried out. So for example, when we say confirmatory, means researchers are testing the hypothesis or existing theories and concepts. And when we say exploratory, means the researchers are searching for latent patterns in the data in case there's no or only a little prior knowledge on how the variables are related. So, but sometimes the distinction between confirmatory and factor exploratory is not always as clear-cut as it seems. So, because of that, for the past 20 years, many quantitative researchers actually have increasingly been turning to second-generation statistical techniques to overcome the weaknesses of first-generation techniques. Okay, so what is structural equation modeling in short? So as I mentioned, structural equation modeling is a second-generation data analysis technique commonly used in research related to sociology, psychology, and other social sciences. And this analytical tool is rapidly growing in popularity due to its ability to overcome the weaknesses of first generation methods, primarily in account for the measurement error in the observed variables. So when we use second generation statistical techniques, we are taking measurement errors into consideration. Okay, so SEM is a powerful multivariate analysis technique used to analyze structural relationships for a hypothesized model. Means a researcher, you may propose a structural model based on previous studies or previous research, previous literatures, and then we can actually analyze the structural relationships among the constructs. So multivariate analysis involves the application of statistical methods, simultaneously analyze multiple variables, and the measurement actually can obtain from surveys or observations, which are quite common in educational or psychological research. We use surveys and observations to collect primary data, but at the same time, they may also obtain from databases consisting of secondary data. So this is the strength of using SEM in statistical analysis. And to cut it short, when we say SEM, we are talking about PLS-SEM and CB-SEM. So basically, there are two types of SEM approaches: covariant-based SEM and also partially squared SEM. So what is the difference between the two? So CB-SEM is primarily used to confirm or reject theories. Okay, and if we want to confirm or reject a theory, an established theory, so we need to use CB-SEM. And it does this by determining how well a hypothesized theoretical model can estimate the covariant matrix for a sample data set. Okay, and CB-SEM also estimates the model parameters by minimizing the discrepancy between the estimated and sample covariant matrices. So these are the theoretical background of using CB-SEM. But when we say PLS-SEM, it actually emphasizes on prediction and primarily used to develop theories. So it is contradicting with CB-SEM. CB-SEM is meant for confirming or rejecting a theory, but PLS-SEM actually is developing a theory in exploratory research. And it does this by focusing on explaining the variance in the endogenous construct. So there are a lot of statistical jargons in SEM, and I will briefly explain later. So the purpose of using PLS-SEM is to explain the variance of endogenous construct when explaining the model, and it maximizes the explained variance of the endogenous construct by estimating partial model relationship. Okay, and if we compare PLS-SEM with CB-SEM, PLS-SEM is actually less stringent in terms of the assumptions needed to use PLS-SEM. For example, in terms of normality, if you want to use CB-SEM, the data must be normally distributed. But when you talk about PLS-SEM, it is not one of the assumptions required. Okay, so when do we use PLS-SEM and when do we use CB-SEM? Actually, both SEM approaches are precise in measuring interrelation among the latent constructs, but the research context will determine which approach is more appropriately used. So the researcher should know the purpose of the research and the research context of the research, so that he can actually decide which SEM should be used. So each approach is appropriate for a different research context. Researchers need to understand the differences in order to apply the method correctly. So to answer the question of when to use PLS-SEM and CB-SEM, researchers should focus on the characteristics and objectives that distinguish the two methods. Okay, in situation where theory is less developed, researchers should consider the use of PLS-SEM because it is exploratory, and as an alternative approach to CB-SEM. And this is particularly true if the primary objective of applying structural modeling is prediction and explanation of targeted endogenous construct. So researchers need to apply the SEM technique that best suits their research objective, data characteristic, and model setup. Okay, because our time is too short for the presentation. So maybe I just want to show you what are the stages involved in using PLS-SEM, because if you compare CBSEM and PLS-SEM, actually PLS-SEM is preferred. Okay, so there are 6 stages involved in PLS-SEM. The first one is specifying the structural model. The second is specifying the measurement models. Stage 3, data collection and estimation. Stage 4, model estimation and the PLS-SEM algorithm. Stage 5, assessing the PLS-SEM results on the measurement models. Especially, we have 2 types of measurement models, which is reflective and formative. And the last stage is assessing the PLS-SEM results for the structural model. Okay, maybe can you please show the slide number 12, specifying the structural model. So I have 2 structural model to show you here. So if you look at the slide number 12, so the right hand side, so we have TSEB and TM. TSEB is teacher self-efficacy beliefs. TM is teaching motivation. So these 2 are considered as the exogenous constructs. And at the end of the model, we have BIITS, which stands for behavioral intention in teaching science. So this is what we call endogenous construct. And in the middle of the structural model, we have 3 constructs, and these are the mediators. Okay, we have ASTS, CBTS, and PCTS. So this is what we call a structural model. And this structural model was actually developed based on previous studies and literatures. Okay, after we have decided on the structural model, we will go to the measurement model. And when we say measurement model, there are 2 different types of measurement model, which is displayed on slide number 15. So we have what we call formative and reflective, and there is a guideline for choosing the measurement model as proposed by Head et al. 2017. Okay, after the specifying the measurement model, we will have data collection and examination, and for us to avoid the error components, we need to screen our data for missing data, suspicious patterns, outliers, and data distribution. And the stage 4 is model estimation and PLS algorithm. And what is more important is stage 5 and stage 6, where we will assess our measurement models as well as our structure model. So if you look at slide number 19, table number 3, we have a lot of criteria that need to be used to examine our measurement model, be it reflective measurement model or formative measurement model. And there are a lot of thresholds, values that we need to meet. So finally is the structural model. Same thing happened. There is a list of criteria that we need to fulfill. For example, we have collinearity between prediction construct, significance and relevance of past coefficient, coefficient of determination, effect size, and predictive relevance and effect size. So at the end of the presentation, actually, I'm sharing with you one of the example of a structural model with all the past coefficients and also the coefficient of determination values. So I think that's all. Because of the time constraint, I think that's all I need to share with you. So for all of you who are interested to this presentation, you can actually get a copy of the talk from the organizer. Thank you very much.